Time is the one thing you trust, without ever seeing it. You watch shadows move across the ground, seasons replace one another, stars drift through the night sky, and your own reflections slowly change over the years. Every experience reinforces the same quiet belief. Time is flowing, carrying everything with it. Yet beneath that certainty lies a question so unsettling that even modern physics has not answered it. What if nothing is actually flowing at all? That possibility sounds impossible because your entire life is built around the feeling of moving from yesterday toward tomorrow. You remember the past, experience the present, and imagine the future. It seems self-evident. But history has repeatedly shown that the universe rarely behaves according to what feels obvious. The sun appeared to orbit Earth. Matter appeared perfectly solid. Space appeared completely empty. Every one of those certainties dissolved when science looked deeper. Time may be approaching the same moment of transformation. For centuries it was treated as the invisible stage upon which every physical event unfolded. Newton imagined it as absolute, ticking identically everywhere in the cosmos, whether anything happened or not. It was the ultimate constant, untouched by gravity, motion, or observation. Then Einstein changed everything. Space and time merged into a single fabric known as spacetime. Suddenly, time was no longer universal. It could stretch, slow, and even differ between observers moving along different paths. The comfortable certainty of one cosmic clock disappeared forever. Yet Einstein's revolution created a deeper mystery instead of solving the old one. His equations describe how time behaves under gravity and motion with extraordinary accuracy, but they never explain why you experience a present that seems to move continuously forward. They describe relationships between events. They do not describe a flowing now. That distinction is easy to overlook because change feels inseparable from time. You watch waves crash against a shoreline, leaves fall from trees, galaxies rotate, and people grow older. It seems obvious that these changes require time to flow. But physics quietly asks a different question. Do these events prove that time itself is moving, or only that physical systems evolve relative to one another? Imagine watching a movie projected onto a screen. Every frame differs slightly from the previous one. Characters walk, planets explode, civilizations rise and fall. The story appears to unfold naturally, yet nothing inside the film is actually moving through time. Every frame already exists. Motion emerges only because your mind experiences those frames in sequence. Some physicists believe reality may operate in a surprisingly similar way. According to the block universe interpretation, every event occupies its own position within space-time. The past has not vanished. The future has not yet been created. Both simply exist at different locations, inside one complete four-dimensional structure. If this interpretation is correct, then your birth still occupies its place within space-time just as securely as this present moment. Likewise, events you currently call the future may already possess their own locations, even though your conscious awareness has not experienced them yet. Reality itself would not be unfolding. Only your experience of it would. At first, this idea feels almost impossible to accept because it conflicts with your deepest intuition. Every instinct insists that the future is open while the past is fixed. But intuition has misled humanity before. The Earth feels motionless despite orbiting the sun at nearly 30 kilometers every second. Common sense evolved to navigate everyday life, not to understand the architecture of the universe. Modern physics therefore forces an uncomfortable question. If every observer can measure time differently, and if no experiment has ever detected a universal flowing present, what exactly are you experiencing when you feel time passing? Surprisingly, physics offers no direct answer. It defines intervals between events with astonishing precision. It predicts how clocks behave under extreme gravity. It calculates the evolution of stars across billions of years. Yet, nowhere does it identify a physical mechanism carrying reality from one instant into the next. Perhaps that omission is insignificant, or perhaps it is pointing towards something far more profound. Throughout the history of science, some of the greatest discoveries emerged not from what equations contain, but from what they quietly lacked. The absence of absolute space transformed physics. The absence of the luminiferous ether transformed our understanding of light. Perhaps the apparent absence of a universal flowing time is preparing us for another revolution just as extraordinary. To understand why, you must briefly set aside the immense scale of galaxies and black holes and instead examine the most sophisticated object known to exist anywhere in the observable universe, the human brain. Because if the flow of time is not written into the fabric of reality itself, the place where that flow is created may not lie somewhere beyond the stars. It may exist inside the remarkable system responsible for constructing every conscious experience you have ever had. And that possibility changes the mystery completely. Instead of asking whether the universe contains flowing time, you begin asking whether the sensation of time is one of the greatest achievements of consciousness itself. Every experience begins long before you become aware of it. Light reflected from distant galaxies enters your eyes as photons. Tiny pressure waves strike your ears. Countless receptors throughout your body detect movement, temperature, and touch. None of this information arrives as a finished picture of reality. Before a single conscious thought appears, your brain has already begun assembling millions of independent signals into what feels like one seamless moment. This construction happens with astonishing speed. To you, the present feels immediate, but neuroscience tells a different story. Conscious awareness lags slightly behind physical events because the brain requires time to collect, compare, and interpret incoming information. The now you experience is not raw reality. It is an incredibly sophisticated reconstruction. Imagine standing inside a vast concert hall. A percussion strike at the back of the orchestra reaches you moments after the violins near the front. Light, reflecting from the musicians, arrives almost instantly, while sound travels much more slowly through the air. Yet you never experience these signals separately. Your brain synchronizes them into one perfectly coherent performance. The same hidden process shapes every moment of your life. Information from different parts of your body travels at different speeds through different neural pathways. Despite these delays, consciousness stitches everything together into a unified present so convincingly that you never notice the enormous amount of processing happening behind the scenes. This alone raises a remarkable possibility. What if the present is not discovered, but constructed? What if your brain is constantly assembling countless independent events into a narrative that feels continuous simply because discontinuity would make survival almost impossible? Evolution never required organisms to perceive objective reality perfectly. It required them to react effectively. A brain that organizes information into one stable experience has a tremendous advantage over one overwhelmed by disconnected fragments. Perhaps your experience of flowing time evolved for the same reason, not because it mirrors reality exactly, but because it allows you to navigate reality efficiently. Modern neuroscience strengthens this possibility through another surprising discovery. Your brain is constantly predicting the immediate future. Before a tennis ball reaches your hand, your nervous system has already estimated where it will be. Before someone finishes speaking, your brain is already anticipating the next sounds. Conscious experience is built not only from perception, but also from prediction. Every second, therefore, becomes a negotiation between memory, expectation, and incoming sensory information. What feels like an immediate present is actually the brain's best real-time model of reality, continuously corrected as new information arrives. If your conscious experience depends so heavily on prediction, then perhaps the sensation that time flows belongs less to the universe than to the machinery interpreting it. The flow could emerge from the sequential way consciousness processes information, rather than from space-time itself. While neuroscience approaches the mystery from inside the mind, physics arrives at a surprisingly similar crossroads from an entirely different direction. Many of the equations describing elementary particles remain almost unchanged if time is mathematically reversed. At the smallest scales, nature often appears strangely indifferent to whether events proceed toward what humans call the future or the past. Yet your everyday experience insists otherwise. You remember yesterday but never tomorrow. A broken glass does not spontaneously reassemble itself. Smoke disperses through a room, but never gathers neatly back into a candle. Every ordinary event appears to possess a preferred direction. The explanation most physicists accept today is not that microscopic laws create an arrow of time, but that probability does. This idea is captured by entropy, one of the most misunderstood concepts in science. Entropy is often described as disorder, but at its heart it measures how many different arrangements are available to a physical system. Consider releasing a single drop of ink into a glass of clear water. The molecules spread naturally until the color fills the container. Nothing in the laws of physics forbids those molecules from returning to their original arrangement. It is simply so statistically improbable that the event becomes effectively impossible within the lifetime of the universe. Everywhere you look, nature follows the same tendency. Hot objects cool, stars consume their fuel, galaxies merge, mountains erode. Physical systems move toward states that can exist in vastly greater numbers than the highly ordered conditions from which they began. Suddenly, the familiar arrow of time no longer appears fundamental. It begins to resemble a consequence of probability. Reality evolves toward increasingly likely configurations, while conscious observers interpret that irreversible progression as the passage of time itself. But this explanation immediately exposes another mystery. If entropy has been increasing since the beginning of cosmic history, then the early universe must have existed in an extraordinarily ordered state. Out of almost limitless possibilities, reality appears to have begun in one of the rarest configurations imaginable. That unlikely beginning made everything else possible. Without such remarkable order, stars might never have formed, chemistry might never have become complex, planets might never have emerged, and conscious observers capable of questioning time would never have existed. Every answer, therefore, uncovers another question. Entropy may explain why time seems to possess a direction, but it cannot explain why the universe started in precisely the condition required for that direction to emerge. Increasingly, some physicists suspect that the missing ingredient is neither matter nor energy, but information itself. Every interaction leaves traces. Every event alters relationships between particles. Memory becomes possible because information about previous states remains encoded throughout the physical world. If memories are simply information preserved by the universe, rather than evidence of an invisible river carrying reality forward, then the deepest mystery is no longer why time appears to pass. The deeper mystery is whether anything has ever been moving through time at all. The mystery deepens when gravity enters the story. According to Einstein's general relativity, gravity is not an invisible force pulling objects through space. It is the curvature of space-time itself. Massive bodies like stars, neutron stars, and black holes reshape the geometry around them. As that geometry changes, so does the rate at which time is measured. This prediction once sounded almost unbelievable, yet it has been confirmed countless times. Atomic clocks, carried aboard satellites, tick slightly faster than identical clocks resting on Earth's surface. Without correcting for this difference, GPS satellites would accumulate navigation errors of several kilometers every single day. Every time your phone calculates your location, it quietly depends on Einstein being right. These experiments reveal something extraordinary. There is no single universal clock governing the cosmos. Two observers following different paths through space-time can experience different amounts of elapsed time before meeting again. Neither observer is mistaken. Each clock faithfully records the geometry of the journey it has taken. Already, this challenges the intuitive picture of time as one continuous river flowing identically everywhere. Instead, time behaves like something woven into the structure of space-time itself, capable of stretching and compressing, depending on gravity and motion. Yet, an even deeper puzzle appears when physicists attempt to unite general relativity with quantum mechanics. Individually, these theories are among the greatest achievements in scientific history. General relativity explains gravity across cosmic distances. Quantum mechanics predicts the behavior of matter and energy at microscopic scales with astonishing precision. But when researchers try to combine them into a single description of reality, something unexpected happens. Time begins to disappear. One of the best-known attempts to describe the universe as a whole is the Wheeler-DeWitt equation. Unlike many familiar equations in physics, it contains no explicit flowing time. The mathematics appears capable of describing the entire universe without requiring a universal clock steadily carrying events forward. Physicists refer to this as the problem of time. It does not prove that time is unreal. Instead, it suggests that what you experience as time may not belong to the deepest level of physical reality. It could emerge only after countless quantum relationships combine into the large-scale universe you experience every day. Imagine standing just centimeters away from a giant painting. At first, you see only isolated brushstrokes. Each color appears disconnected from the next. Only after stepping backward does the complete landscape emerge. The image was never hidden inside a single brushstroke. It appeared because millions of tiny details formed something greater together. Some researchers believe time may emerge in exactly the same way. Individual quantum interactions may possess no universal temporal flow. Only when unimaginable numbers of those interactions organize themselves into stars, galaxies, planets, and observers does the familiar experience of past, present, and future appear. This possibility has inspired several fascinating theories. One proposal suggests that different parts of the universe effectively serve as clocks for one another. Instead of measuring change against an external flow of time, physical systems measure change through their relationships. Time becomes relational rather than absolute. Another perspective argues that reality is fundamentally built from interactions instead of isolated objects. If relationships are more fundamental than independent things, then time itself may simply describe how those relationships evolve. In this view, asking where time exists becomes as meaningless as asking where the center of a rainbow exists. The phenomenon is real, but it emerges from deeper processes rather than existing independently. None of these ideas has been experimentally confirmed. They remain active areas of research, debated by physicists searching for observations capable of distinguishing one interpretation from another. That uncertainty is not a weakness of science. It is evidence that humanity has reached the frontier of current knowledge. Yet every major scientific revolution began in precisely this way. Questions appeared before answers. Equations hinted at patterns long before experiments confirmed them. The deepest discoveries often emerged because researchers dared to question assumptions that had once seemed beyond doubt. Perhaps time will eventually prove to be fundamental after all. Or perhaps future generations will discover that it emerges from principles even deeper than space, matter, and energy. Either possibility would transform our understanding of existence. Until then, every ticking clock reminds us of something profoundly humbling. Clocks never measure time itself. They measure change, the sensation that change is flowing through an invisible river may belong not to the universe, but to the extraordinary consciousness interpreting it. If that possibility is true, then the greatest mystery is no longer whether time is real. The greatest mystery is what reality truly looks like when you remove the illusion that it was ever flowing in the first place.